carefully here. What do you think is going to go in there? Would you want the units of that file to go in there? Is it inches, millimeters? Would you want the version of the software that was sending it out? I mean, what kind of information would you like to send? Well, there's a list of all these things. So the first two things that you have to send it are the characters that delimit the data. Okay? And when you end a record and when you start another. So the first two are kind of nonsense characters, but then there's the file name, there's the native system ID, the processor version, the number of bits in a word, the accuracy of the system. All of that stuff is contained in it. Why do you need to know that?
Would probably affect how you would interpret the data or how the computer would.
Yeah, so if you're just throwing this out of system A and it's sitting there in a text file, the first thing that you want to do with that is pull it into another system. And if you don't know whether you're on a 16-bit, 32-bit, 64-bit machine, if you don't know how many decimal places of accuracy you're tracking, you don't know whether it's inches or millimeter, you're going to have no clue as to how to read the rest of the data. So right up at the beginning of this file, it just says, here's everything that you need to know to baseline how to interpret the rest of the data. So how does that look? Well, here's 4 lines of that section translated in. So this very first thing is an H1 comma, and again, this is historical. When you were using punch cards, you gave it hollerith characters, and you had to tell it how many hollerith characters you were giving it. So in this case, it's saying, I'm giving you 1 hollerith character. What is the character? A comma. What does the comma represent? It's the delimiter between each bit of information coming in. So it's a comma followed by a comma, because I now know that this comma delimits information. And what's the next bit of information? Well, again, 1 hollerith character, and the character was, how do I know when I've ended a record? And so it's a semicolon. And so I look here with a bunch of commas all the way through this thing, and what do I see at the very end? A semicolon, which says I'm done with this global section. So I know it's a little bit, why is Dr. Jensen trying to wrap my mind around this? But it's trying to explain to you that this is an established standard that you can work with, you can interpret, you can read. Now, do we really want to read this thing? No. But in your 30 years or 40 years of career, could you potentially be given something that you'd have to open up and say, I need to make sense of this? Yeah. And so understanding how a standard is written and how it's interpreted, I think is at least worth a few minutes. So that was a global section. We're now looking at the directory section. The directory section will contain 2 lines, and the 2 lines will be there for every entity and for every entity in the file. What do those 2 lines contain? Well, it contains stuff like the line font. It contains what level this line was on. It contains what view it was visible in, whether it's visible or not. Does some transformation matrix get operated on this entity? If so, where do I find the transformation matrix? So some of these are just values, and others are pointers to a place down in the data record where I can find the actual transformation matrix. Here's a list of the entities. So the very first thing was an entity number. So what are the entity types? Well, here's a 110 that's a line. Down here we've got some rational B-spline curves. We've we've got a surface. And if we go all the way over to the right-hand column, we'll find things like a block, which is a solid. We'll find a wedge, a cylinder, a cone, a sphere, and eventually we see a solid of revolution and a linear extrusion. And that's all of the entity types that you can actually build or represent inside of IGES. So here's our two lines. A 110 was what? It was a line. So this is a record about a line. And this information that's in this tabular column format is trying to tell it, is it on a certain layer? Does it have a certain line type? Is it a dashed line, a center line? Does it have a certain color? This line is pretty generic because most of these things are zeros, okay? So it's just a basic line. (106) Copious data. What does that sound like? What does copious data sound like? Extra baggage. Does it sound like extra baggage? Does it sound like anything I don't understand? I can call it copious data. Anything I can't write out of my CAD system, it's not in the standard, where can I tuck it away? I can tuck it away in copious data. Is anybody going to understand copious data? Okay, copious data. There's a kind of an explanation of what it is. It's extra stuff that the standard doesn't really kind of address and understand and work with. What controls, who controls a special meeting? What problems could this cause? If I have an entity type different than the list that's there, I write it out as copious data. Is the receiving system going to know how to do anything with what I stuck in there? They're not unless I tell them. If I tell them, here's my copious data and here's how I represent it, it's not covered by the standard. Could the receiving system do something with it? Yeah, they would have to do an extra program to make it work or fit. So in the directory section, was there anything about the beginning point or ending point of a line? Was there anything in there that said, my curve goes through these points? My solid has this kind of dimension to it. Was any of that information there? No. It's contained in what's called the parameter section. And so an example of the parameter section for a line, it would contain an XYZ at the beginning point, an XYZ at the ending point, exactly what we would expect. And so looking in the program that's in your book, it has the entity type, so this is a line, and this is XYZ at the beginning and XYZ at the end point. Okay? So it goes from 0, 0, 0, 0 to 0, 2 in Y, 0 in Z. And this is kind of the rest of the file that's in your book you can look at. That file that's in there, you could just as easily kind of read. Here's a 128. What's a 128? For those of you that have your book open, look at the thing. What's a 128? It's a rational B-spline surface. And so if I look, there's all of this information on the first row, there's all of this information on the second row, and then all of a sudden I hit a 126. So these two rows, starting by the 128, those XYZ values, or those parameters, what do you think they're going to represent? The control net of how that surface is defined. A set of points that define the shape of that actual curve. And mathematically, a B-spline, given 16 control points is always going to look exactly the same. It doesn't matter whether it's on system A or system B, it'll be able to reproduce that surface perfectly. And then it has an ending section. And the ending section, the only thing that's worth noting there is this says there's one line in the start section, there's 4 lines in the